I want to now give a kind of bird's eye view of the subjects of the rest of the course after giving the historical perspective. So I will stop this part. I guess I just leave Palmer's picture there for the time. I don't have another placeholder picture. So I want to give what I call a bird's eye view of the main topics in this course. And then we'll start jumping into the details. I believe my bird's eye view will fill the rest of today, and then we'll be ready to go further in detail.
You say hypnosis part of VR?
I don't know. Hypnosis part of VR. That's very good. Maybe that can be a good class project. So. Okay, bird's eye view. So I first suggest picking a sensor on your body. So pick a sensor, and I think another word for this could be sense. You know, I have an engineering background, so for devices we make we call them sensors. If it's on your human body, then people will call it a sense or a sense organ to refer to the particular part that's doing the sensing. If it's the whole system together going all the way into your brain, then maybe it's called the sense. So I may use the word sensor and sense interchangeably. It's hard because I have a lot of engineering background, so it's fine. Pick a sensor on or in your body. All right. So eye, ear, perhaps your skin somewhere like on your fingertip. If we want to involve taste, we can have tongue, we can have nose for smell. What is a sensor? Anybody have a good engineering definition of a sensor? Anyone thought of that before? A sensor is usually considered to be a form of transducer. A transducer converts energy from one form into another. And a sensor is usually considered to be a transducer that converts whatever physical energy it's measuring, right, from the physical world into signals of some kind. Right? If it's a digital circuit, then it'll convert it into digital signals. If it's your brain, then the sensor should be converting it into neural pulses. Right? So it's a signal of some kind that goes into the system. So it's a kind of transducer. So one thing to pay a lot of attention to, which will be very important for us with these various sensors when we pick one, is that each sensor, and this will, if you understand this, it'll help with a lot of potential confusion later. So each sensor moves through a space or changes in some way more generally. So each sensor moves through space. These changes are controlled by the brain and the central nervous system together. So controlled by the brain and your central nervous system. And one thing that's important to pay attention to, and this is also important in robotics, can't help emphasizing this, and it's very important to think about, is what are the degrees of freedom? Degrees of freedom for each sensor or sense. You can abbreviate it DOF. People even pronounce this, they call them DOFs. So how many DOFs does that sensor have? How many degrees of freedom does it have? And this is a very important thing. And so each sensor, I'll squeeze this down here, each sensor has a space of configurations. So a let's say configuration space. So in other words, the set of all ways to transform or move that sensor or reconfigure that sensor. It's a very important thing to take into account, and our bodies are changing the configurations of our sensors all the time without telling us, right, without being consciously aware of that. So this is something we have to train ourselves to pay a lot of attention to. If you do that, then you will understand these things better. So let me give some examples. Use EX for example. So let's think about your left ear. I just want to pick one ear right now to make it clear. So pick your left ear. If we look at the position part, position, take my left ear, I can go back and forth, right? I can go forward and backwards, and I can go down and up, right? So that's 3 degrees of freedom for position. So I'll say there's 3 DOFs from that. However, I can also rotate my ear in various directions, right, like this as well. So there's 3 degrees of freedom from rotation. So the total is 6 DOFs. Right, so I have 6 degrees of freedom because let's say it's a rigid body moving through space, right? So as I'm walking around here today, my left ear is traveling through a 6-dimensional space of configurations. Everyone agree with that? Seems fine. Some animals can bend which way their ears are pointing. That would be more degrees of freedom. We don't have that in our ears, but our eyes do, right? So that's very interesting. So if we have another example, let's just to give equal weight to both sides, we'll pick our right eye. Clearly it doesn't make much difference. So it's more complicated, right? We clearly have the 6 DOFs that correspond to head movement. Head and body movement actually, right? Your whole body can move, can cause your head to move around, which causes your eye to appear somewhere different. However, I can hold my head fixed and then I can start rotating my left eye around. I can't do it by itself. I guess I'm rotating my right eye as well. How many degrees of freedom do I have with this eye as I rotate around? 2 or 3? Roughly 2, let's say. So you can look up and down and side to side. There's a little bit of torsioning or twisting that happens, but it's more or less 2-dimensional. I talked to some neuroscientists about this recently, and there's a little bit of a 3rd dimension, but I think 2 is just fine. So there's rotation. Of the eye. So maybe that's 2 DOFs. One more interesting thing happens, especially if you're younger than about 48 years old, then your eye has an additional ability to refocus. So when you bring things very closely, your eye muscles are changing your lens so that you can look at things very closely. So if children show you something, they can put it like right up to your face, but you can't focus on it anymore if you're over 40 years old probably, or especially if you're over 50. So we lose the ability to do that. However, that's one more important thing. So it refocuses. Refocus. Scientists refer to this as accommodation. So in engineering we would call that focus, but anyway, so it's good to know the word for it. So so the eye can accommodate. So I guess if I put all of this together, maybe this ends up with about 9 DOFs. If I consider focus to be a single parameter, I get 6 plus 2 plus 1 for this. So I have all of these degrees of freedom, and we're barely aware of it, right? Very often. Right. I want to give one abstract view, draw a picture here, and then I'll finish up this part, and then we'll take a break. the most important thing, degrees of freedom. Think about the degrees of freedom of your senses all the time. If you're testing virtual reality systems or developing them in some way, this becomes very important, and it's easy to ignore because we're trained to ignore it. Our brain's not causing us to pay attention to that. So I want to give a kind of abstract view a bit simple, maybe a bit not too serious, but take the human brain here and we have this sensor or sense sensor. Another way we might call it the sense organ, and it's providing information to the brain through neural impulses, and the brain in some way is controlling the configuration. Some of the control may actually bypass the brain and be very low level. An example of that is the vestibulo-ocular reflex, which I will cover very soon. I'll cover it in the next part, but let's just say generically the brain is doing the control, and then the sensor is capturing information through transduction from the outside world. So there's this world out here, right, and this is what I would call the normal situation without doing any kind of virtual reality yet, right? And so the question now is, what can I put in this what can I put in the physical world to try to fool the brain? Well, I go over here to the sensor and I look at the information coming in, or I look at the stimuli coming in, and I want to replace this with something that's been engineered. So let's try that. So it's still the world. Let me because you're not going to leave the world when you put on a virtual reality headset, right? So that's still there. So the world is still there. And then what I do is I make something called a display for whatever just kind of displays appropriate for this sensor that I've picked. Again, it could be touch, could be vision. So I want this display to provide the stimuli to the sensor, and then I have to figure out what to put on the display, so I'd better make some kind of box here which I will call an alternate world generator. I don't know if I want to call it a virtual world generator because it may be somehow maintaining a representation of an alternate world. It could be a real world somewhere far away, some other location. It could be recorded, delayed by some amount. It could be completely virtual, but some kind of alternate world generator is going to have to be constructed, and that's one of the things we'll get into. And through the process of what's called rendering, tiny letters here, rendering, the process of rendering, we take the information constructed by the alternate world generator and it's rendered to a display that provides the sensory stimulation so that the brain is fooled, so that hopefully the picture, by the time you're done, I think I'll just draw it in a different color here. So what the brain believes by the time you're done is it doesn't see any of this stuff. It just imagines, let's see here, it just imagines that there's an alternate world and that's all there is to it, right? So the brain does not understand any of this stuff, right? It's something that we on the outside, the scientist, can see it if you like, right? But if you're putting on the headset, you become the laboratory rat, so you cannot really see the yellow part from the brain, from your brain's perspective. It's just the alternate world that is where you feel present if everything's been done correctly. Questions about that? Sorry, the sensor?
Has to be an eye or can be any other sense?
No, I mean any human body sense that you like. So it could be
Because you're display.
that's right. And as I'll mention in the next part, we'll take a break here in a bit, but in the next part I want you to think about a display as being an engineered device that presents stimulation to your senses. right. So, simple example, an audio display is called a speaker. That's a good question because normally we just use display for video. We call these things on the laptops here a display. This is a display, but I want a speaker to be a display. I want you to think very generically like that across all of the senses and constantly make comparisons across the different senses. Say, well, why was it important for this sense and not for this other sense? These are good kinds of questions to ask, and that's the motivation for calling them all displays. Trying to get to the fundamentals here, right? So trying to really think about what's common across all of these. Very good question. Any others?
Like we control only one sense, other senses are free to feel the world.
Yeah, that's a good question. So I've just drawn it for one sensor, but of course I can make an array of sensors here and then an array of displays with rendering, and I'm going to draw this picture next time. I will have an alternate world generator feeding to all of those. And then we can say how many senses are enough, how many do you need to take over, and I will just say, well, whatever's sufficient for your task, right? Whatever's adequate for the task. What's your goal, right? Do you want to feel fully immersed like you're hanging out with your friends and socializing and having a good time? Is that enough? Fine. Do you need smell in that case? I don't know. It just depends, right? So what senses do we need? Vision is the most powerful one by far. Audio is probably next most powerful. Haptic maybe next. I don't know what way we want to order these, but I don't think anyone's going to disagree with vision being the most powerful sense that we have, and it does require the most neural processing out of any of our senses. So that's what makes this these current times very exciting, because we've felt audio immersion for quite a while now, but visual and then the two of them together is very powerful. So having haptic or touch feedback as well would be even more powerful and necessary in some tasks depending on what the task is. So we always have to think about what is the task and what's adequate for that task. Right? If I want to train a doctor to do some kind of stitching, let's say on skin, and I provide no physical force feedback whatsoever in the simulation, it's going to be very hard for them to get it right. Right? They'll just have to do it in the physical world only. So if you want to, in that case, you need to provide force feedback. If I'm going to socialize with my friends, probably don't need that, right? So it just really depends on the task. All right, other questions?